In this video, we're going to look at some applied questions of differentiation. So this question shows a block. It's basically a cuboid that measures 2x by x by y. And it says that the total surface area of the block is 600 centimeters squared. Show that the volume of the block is given by V equals to 200x minus 4x cubed divided by 3. Given that x can vary, use calculus, that means differentiation and integration, in our case differentiation, to find the maximum value of V, given your answer to the nearest centimeter cubed. Part C says to justify that the value of V you found is a maximum. So what we're going to do is start off with part A and say, right, okay, so we know that the total surface area is 600 centimeters squared. So I'm going to find the area of each of these. So I'm going to find the area of the front face. That's going to be 2x by y. So I get 2xy. Notice that there's a back of this block that has the same area. So it's another 2x plus y. Then in grey here, we've got 2x times x, which is 2x squared. Then the other side is also 2x squared. And then the top, sometimes you've got to be careful. Sometimes they say that a container has no lid, but in our case it does. So the block has a top. So in our case, it'll be x times y on the top and also x times y on the bottom. So I'm going to write plus xy plus another xy. Now, if I simplify this down, I get 2xy plus 2xy, and I've got another set of 2xy here. So that gives me 6xy in total. Then 2x squared plus 2x squared gives me 4x squared. That is what my total surface area of the block is. Now that's equal to 600. Now notice, in the final answer of the volume, they don't have a y. That means y has been eliminated. So what I'm going to do in my case here, I'm going to make y the subject. So 6xy equals to 600 minus 4x squared. And then I'm going to divide by 6x. So I'm going to divide both of them by 6x respectively. So that will give me 100 over x. That will give me 2/3 and then x on the numerator. So now that I know what y is, I can then use the formula from GCSE that we all know, that the volume of a prism is the area of the cross section times by the length. Now the area of the cross section, in our case, I'm going to use the front face here, which is going to be 2x times y. So I get 2xy. Now the length, in my case, I'm going to call this x. So multiplied by x. So that gives me the volume is 2x squared y. Now I know what y is. Y is all of this. So I'm going to say 2x squared. Now I'm going to write y in red so you can see it. So it's 100 over x minus 2/3 x. So we can multiply this out now. So 200x squared divided by x minus 4x cubed over 3. Now the x squared and the x will cancel, so I get v equals to 200x. Again, just reiterating that the x squared and the x will cancel to give me x, so I get 200x on the numerator minus 4x cubed, all divided by 3. Now part B says, use calculus to find the maximum value of v. Now in a question like this, we would have to differentiate it, find the first derivative, and make it equal to 0. So we can say that dv by dx, we differentiate it term by term. So that's going to be 200x differentiated is simply 200. Keep the constant 4 over 3 on the outside. Bring the 3 down and reduce the power by 1. So we get an x squared. So now we get 200. The 3 and the 3 cancel. So I get 4x squared. Now maximum and minimum occur when the first derivative equals 0. So maximum and minimum when, in our case, dv by dx equals 0. In our case, it's a maximum value. So we're going to set 200 minus 4x squared equal to 0. So we get 200 equals to 4x squared. So dividing that by 4, I'm going to get 50 equals to x squared. So x equals to plus or minus the square root of 50. So if we now go back and read the question for the next part, we need to find the maximum value here. So I'm going to put in positive 50 because it's a volume. So we know what the volume formula is. So it's going to be v equals to 200 times root 50 minus 4 times root 50 cubed, all divided by 3. Get my calculator out. I'm going to round this to the nearest centimeters cubed. So it's 200 times root 50 minus, press the fraction button, root 50 cubed over 3. And that's going to give me 943 to the nearest centimeter cubed. 943 centimeter cubed. Now, if we go back to the question, it says justify that the value of v you have found is a maximum. So remember how we do this. We've got to find the second derivative now and substitute this value of x, and what we want to do is get a negative value for the second derivative. So we can write d2v by dx squared. So we differentiate this for the second time now. So we take our first derivative and we differentiate it. So that's going to be minus 8x squared. Now, because we want the overall result to be negative, I'm going to put positive 50 into this equation. So when x equals positive root 50, this will now give me d2v by dx squared is minus 8 times root 50. Now, because the answer is negative, I'm going to say since d2v by dx squared is negative, therefore we get a maximum value.